Welcome to this week's video. Today we're going to be doing another LeetCode problem, and for this week I picked number 3354, that is make array elements equal to 0. That's an easy problem, and that's going to be an array problem. So let's read here the description. It says that we're given an integer array nums, and we start by selecting the starting position cur such that nums at that position equals 0. And then choose a movement direction of either left or right. After that, you repeat the following process. If cur is out of the range 0 to n-1, that is, if cur is outside of our list, the process ends. Second here, it says that if the number that we're looking at the current position is 0, move in the current direction by incrementing cur if you're moving right, or decrementing cur if we're moving left. So we're going to be given two options of either moving to the right, in which case we increment our index cur. If we're moving to the left, we're going to be decrementing our index cur. And here it says that after moving our index, if the number of that new index is greater than 0, we must decrement cur by 1, right? And then we're going to be reversing our movement direction. So left becomes right and right becomes left. And then you take a step in the new direction. That was very complicated to follow, but it's going to make more sense once we look into the examples. But it says here to a selection of the initial position cur and movement direction is considered valid if every element in nums becomes 0 by the end of that process. Return the number of possible valid selections. Okay, it was a lot to cover here because of these rules, but let's look at the example because it's not as hard as it looks here. I think it makes more sense to look at the example and see what they mean. So it's pretty much telling us to look at a given nums array here. That's going to be an integer array. And it's going to be telling us to start at either one of the zeros. So there are going to be a lot of some zeros in this array. And we need to find a certain how many different ways, right, we can follow all this process and at the end get a array full of zeros. And the way I like to think about this problem is kind of thinking like one of those games where you need to break blocks. So you imagine like you have a little ball, and then this ball is bouncing back and forth, and then every time it hits a block it decrements its life, let's say. And then once this life reaches 0, you finally break the block. It's kind of like a phone game that used to be famous back then. But so for example here, our position needs to be 0. So let's say we pick this one over here, and we have a little ball. And so we gotta pick a direction, either right or left. And this ball is gonna be bouncing right and left. Every time it hits a number that's not 0, it's gonna decrement the number, and then gonna go back in the other direction. And it's gonna keep bouncing like that, breaking these blocks. And it's asking us if after this process we can get an array that's only zeros. So that is, if we can break all of them, if we can make all of them 0, right, without leaving the array in the process. So let's look at this example here. So let's say I pick the first 0, right? I can either go to the right or to the left. Let's say I go to the right. If I go to the right, I hit this block here, I break it, this becomes 1, and then I bounce in this direction. I hit this one over here, this becomes 0, and I bounce in the other direction. So this one is broken now. This two, it became 1, right? So I break this one here, this becomes 0, and I go into this direction, but now this one became 0. So now I actually leave the array. So I'm actually leaving the array before making everything 0, so that will be invalid, right? However, if we pick this one over here, we're gonna see that I can either pick right or left. We're then able to break all of them. So let's say I pick right. So this little ball is gonna bounce here on the right. This becomes a 2. It comes back here. This becomes a 1. It goes back here. This was a 2. Now it becomes 1. It goes back here. This was a 1. So it becomes 0. We break it finally. And then we come over here. This was a 1. So now we break it. That's 0. We come back over here. Break this one over here. This one becomes 0. And then we finally leave everything, right? So we broke all of them. They became 0. and we know that from this position here, if we go to the right, we can break all of them. I can also prove that going to the left, we can also break all of them. But the important thing here is to notice that there are certain conditions for this to happen, right? So to solve this problem, we can go through all these steps here, you know, like for every single zero, we try right and left and see if we can break all of them. That would be a non-optimal solution. It's gonna take longer. But the other thing to realize here that's gonna make this problem easier is to see that we only need to calculate the amount of numbers or blocks, you know, on the left and on the right, and compare them. So for example, if, you know, we're starting at this 0 here, if the amount of blocks on the left is equal to the amount of blocks on the right, then we can break all of them, no problem, because this ball, it needs to bounce as much left as it needs to bounce on the right. So because there's the same amount, we know that we can break all of them, right? So the condition for this is, you know, if the sum on the left is equal to the sum on the right, then we can break all of them. There is one more actually, and that one is that you're actually allowed to have different sums to the left or the right, as long as one of those sums is only one more, right? If it's one more and you start breaking from that side, that's also a valid solution. So for example, we saw here, you know, the sum on the left here is 3 and the sum of the left here is 3. So we know for sure that's gonna work no matter the direction we start breaking. But what I'm trying to say is that there's another condition where the sum on the right can be different than the sum on the left by 1, as long as we start breaking on the right. So let's say that this is 4, right, instead of 3. This is still valid as long as my ball here starts breaking blocks from starting on the right. So again, let's picture the ball here on 0. Let's say now this is 4, right? This is not 3 anymore, this is 4. We're gonna be starting breaking the blocks on the right. So this ball bounces here on the 4, it becomes 3. And then it goes here on the left, it becomes 1, it bounces here, this becomes 2, bounces here, this becomes 0, bounces here, this becomes 1, bounces over here, this becomes 0, and bounces over back. This was 1, so now it's 0, and then you leave the array over here on the left. So you see, we broke all of them, they were 0 at the end, even though this one, the sum on the right was bigger than the left by 1, and that is because we started breaking things on the right. Okay, that was a lot, but the important thing here is just to understand that to solve this problem, we need to find sums of the array and compare the sum on the left and sum on the right, right? And whenever there's a problem where it asks us to find the sum of an array, it's also a very good idea to use the concept of prefixes. So I'm gonna briefly explain here what a prefix is, but it's a technique that you can use to solve some array problems that requires you to sum stuff in a array. So let's take the example here that they gave us. So 1, 0, 2, 0, 3. That's the example that they gave us. We can then build a prefix array. I'm going to explain what it is from this array. And a prefix array is simply, if you go from left to right on this array, if you keep adding all of those elements and saving the total amount onto the current array, you get the prefix array. So for example here, that will be 1, 1, and then here you add 2, so that would be 3, 3, 6, right? Why is that? Because we have 1 over here, and then we add 0, so this becomes 1. That's why I put a 1 over here. And now that this is 1, we add 2, so 1 plus 2, 3. And then we add 0, 3 plus 0 is 3, and 3 plus 3 is 6. So it's just the cumulative sum, right? You're just going through the array and adding everything and saving what the current total amount is up to that point, right? And why is this useful? This is useful because this allows you to find sums of your array from an index I to an index j arbitrarily, right? So let me write this over here. So for example, let's say the problem asks you to find the sum of elements in indices 2 and 4, right? So we start from 0, so 0, 1, 2, 3, 4. That's element in index 2. That's element in index 4. If it asks you to find the sum between elements in index 2 and 4, it's asking you to find the sum of these three elements, which is 5, right? And the prefix sum allows you to find that in a very fast way. And let me write over here. So the sum of nums from I to j, right? That is going to be equal, there's a formula for that. And the formula for that is the prefix of j minus prefix of I plus nums of I. So it's a formula you gotta memorize, but it allows you to find sums of subarrays much faster, right? So let's take the example that I gave before, like we're asked to find the sum of these three elements here from index 2 to 4. We know it's 5, right? But let's see if this formula works. So this is saying the prefix of j. So our j here is 4 and our I is 2. So prefix of 4, that's going to be 6, right? Because 0, 1, 2, 3, 4. So that's going to be 6 minus prefix of 2. Prefix of 2 is 3. It's the prefix at index 2. So 0, 1, 2. So 6 minus 3, that's 3. So this part here gives you 3. Plus nums at 2, which was here, right? 0, 1, 2. So it's saying 6 minus 3 plus 2, that is 3 plus 2, which is 5, which is exactly what we found here, right? 5. And so that's just a technique that you can use to find sums of subarrays in an array. Okay, now that we have this knowledge over here, I'm gonna keep this formula here on top, and we can actually start solving our problem. So I first like to get the length of our array. That's gonna be nums, right? And the first thing we need to do is to build this prefix, right? So we're gonna need to build a prefix of nums. So I'm gonna declare here a variable called prefix. And that's very standard. I mean, there's ways you can build a prefix, always gonna be the same, but this is how I usually do it. So I usually initialize the prefix to the first number of my array. So that's gonna be nums of 0. And then I iterate over my array, so for num in nums. And I actually start from the second element forward, right? Because the first one we already like included here, num 0. So I actually go from 1 all the way to the end. And then we simply add to our prefix the current number plus the last one in prefix. So prefix minus 1. And this is a formula or like a pattern that you can use to build prefixes. Okay, now that we have a prefix formed, we can declare a variable here, answer, that's going to be 0. And we can actually now iterate through our array nums. So for I in range nums. All right, so we're going to be now iterating over array, and we're only interested in numbers that are 0, right? So if we find something that's not 0, we can just like ignore it. So the first thing I can do here is to ask, you know, if nums of I, if it's different than 0, I don't care about it. I just want to continue to the next one. So that's going to make sure we only stop at the zeros of our array. Okay, once we reach a 0, we need to find the sum on the left and the sum on the right. So let me find here left, define a variable called left sum. That's going to be equal to our prefix at I. And that's also a nice a characteristic of a prefix is that if you want to find the left sum given an array, that's just the prefix at that index, right? For example here, let me give you that same example again. We had here 1, 0, 2, 0, 3, right? We found that the prefix here was 1, 1, 3, 3, 6. For example here, if I want to find, if I'm at index 2, right? I want to find the sum up to that index. All I got to return is the prefix at that index. So if I'm here, the sum up to here is 2 plus 1, which is 3 here, right? If I'm on the last one here, I want to find the sum of all the elements so far. That's going to be 3 plus 2 plus 1, that's 6. So I just return the prefix here of I, right? So for the left sum, it's easy. We just return the prefix of I. Let me delete this here so we don't get problems later. But for the right sum, we use the formula that we talked before. That's going to be this here, right? Prefix j minus prefix I plus nums of I. Yeah, this is not prefix. It's not p. It's called prefix. And here we're going to do prefix j. In our case, j is actually the last element, because we're always going all the way to the end. So that's going to be n minus 1 minus prefix of I plus nums of I. This is just the formula that we talked about here, right? Okay. Now we can actually compare those two sums. So we can do if left sum equals to right sum. If that's the case, we know that it doesn't matter if we start breaking to the right or to the left. We can do both directions, so that's going to increment our answer by 2, because we can either go right or left. However, the other case is if one of those sides has one more than the other. So that's going to be if left sum equals to right sum plus 1, or right sum equals to left sum plus 1. If that's the case, right, if one of those sides is bigger than the other, then we know there's a solution, but only to that specific side. So we only want to increment the answer by 1 over here. And that's pretty much it. Then we go through all of our loop, and then we can return the answer over here. So let's see if this runs. Let me hit submit. We here get a problem. What is that? Oh yeah, it's not range nums, it's range of n. Let's submit that again. And you see here we accepted and we beat 65% of the solution. Sometimes this number here depends on how many times I submitted. Like now it's a bit bigger, but anyways, you see here that we beat a bunch of the solutions. That is just by using prefixes and seeing that we can find sums of subarrays much faster like that. Yeah, but that's pretty much all I had for this video. Thanks for watching, and I see you next time.